Film number 7 covers conversion method number 3, which is the successive approximation method. And the block diagram of an successive approximation converter, so-called SAC, is very much the same block diagram as the one we had with the ramp. There is one small difference. You have the DAC, you have the SRG, which is the digital analog converter, and a storage register. But you have here an SAR, successive approximation register, instead of the counter. So let's give an example here where I ask you to think of a number between 1 and 16 maybe, and between 1 and 16, and I know that the number you thought about was 13. If I were to guess which number you're thinking of, well, my first guess would be 8, and I would ask you a question, is your number higher or lower? If you answer higher, well, then I know that your number is between 8 and 16. So I half that, and I guess my next guess would be 12. Again, you would say higher, and I know that your number is between 12 and 16. My next guess would be 14. And you would have to answer lower. So I know that it's between 12 and 14. My next guess would be 13, and that would be the correct number. So that required that was my first guess, second, third, fourth guess. And indeed, 2 to the power of 4 equals 16. So I made it in 4 guesses. Now, this is the same method here. Instead of trying to guess the number you're thinking of, like with the ramp method, my first guess would be 1, then I would guess 2, 3, 4, 5, 6, 7, 8, 9, and I would require 13 guesses before I hit the number. But now with SAR or SAC, successive approximation converters, I get a lot less guesses before I get the correct number, and indeed I guess the correct number with the same amount of guesses each time, which means that really I'm getting closer and closer and closer and closer to your number. Remember that this is an analog value, so I guess the number that you were thinking of would more precisely maybe be 13.2864 volts, and I can only guess integer numbers, which is numbers without comma, and I get quite close within my 4 guesses. Of course, if I had 5 guesses, my next guess would be 13.5, and I would be even closer. My next guess after that would be 13.25, and you see I'm getting closer and closer and closer to the true value that you hold here. So the same thing, I have SAR, which is a successive approximation register. That one will guess half the value for the first guess. So the voltage out from the DAC would be somewhere in the middle between VDD and ground. That will be presented here, and the comparator here would check, is the number that I have, or the voltage that I have, larger or smaller than half the value. And that will tell the register if it was above or under. And then the next number it's presenting here is based on what it was fed back in the first guess. The second guess will follow this scheme, the idea here. So this results in First of all, the converter is much faster. If I have an 8-bit converter, that would be 256 levels. And with a ramp, that would mean, worst case, 256 guesses before you get the correct number. With a successive approximation method, you only need 8 guesses in order to find the best approximation.